Ever feel like your code is a chaotic mess? Revisions buried like lost socks in a dryer? And collaborating with others feels like a game of telephone gone wrong? Worry no more, developer friends. Today, we'll be conquering these coding struggles with the mighty duo, Git and GitHub. So what is Git and GitHub? Imagine Git is your code guardian angel. It keeps track of every change you make, like a digital time machine for your code. Need to revert to a previous version? No problem. Get to the rescue. But Git can't do it all alone. That's where GitHub comes in. Think of it as your code collaboration fortress. Store your Git repositories on GitHub, work with others seamlessly, and keep your code safe from the clutches of spaghetti monsters. Let's put these newfound superpowers to the test. We'll walk through common Git commands and explore GitHub functionalities. Don't worry, it's easier than learning how to use a lightsaber, but maybe not as cool yet. So, let's dive in. Let's first set up Git on Out Machine. Go to Google and search Git. Click on the first link as shown. Now scroll down and click on Downloads. Here select your operating system, and then download the setup according to your machine specifications. Like in our case, it's x64-bit. Once download completes, install it in your machine according to your needs. Now let's create an account on GitHub. Head over to Google and search GitHub. Click on the first link shown. Click on Sign Up on top right corner. Let's quickly sign up. Once you're done with sign up, you will see the dashboard like this. Here you can create a new repository. Click on Add icon on top right corner and select Create New Repository as shown. Once done, it will ask you your repository name. You can name it anything you like, but for this tutorial, let's call it Git Tutorial. You will see other settings as well, like if you want to make this repository private or public, add readme.md file, license, etc. So choose according to your needs. Once done, click on Create Repository. And congratulations! You have successfully created a new repository on GitHub. Now time to set up in our project. Here we have created a folder which contains 3 text files, masterpiece, not a masterpiece, and readme file, as shown. Now if we try any Git command in this directory, we will see an error like not a Git repository. So, let's initialize Git in our directory. Type Git init as shown. Great. Now we can use any Git command in our project, like Git status, to check the current status of your repository. Now, let's go back and check the next step to set up. Next step is to add all files to the staging area. We can do that by command git add a. Perfect. We have added all our files to staging area now. For those who don't know about staging area is files that are going to be a part of the next commit, which lets Git know what changes in the file are going to occur for the next commit. Let's quickly head back and see the next step, which is commits the staged changes with a message. Use command git commit and then message as shown. Let's commit our changes real quick. You can give any message you like according to your changes. Great. Let's head over and see the next step, which is renames the current branch to the specified new name. It is highly recommended to name it main, but again, it's up to you. Here, we can see we're currently on the main branch. However, some older Git repositories might still use the master branch name as the default. While both work functionally, the Git community has recently standardized on using main as the default branch name. Now let's quickly add a remote repository link named origin. Great. And last and final step, push the changes to the remote repository. To push our changes, we'll use the git push command. In our case, we'll be pushing to the main branch of our remote repository on GitHub. Here's the command: git push origin main. Great. Let's head back and reload the page. And congratulations, you have successfully pushed your project on GitHub. Here you can check all of your team commits, branches, and more. Excellent. Your code is now securely stored in your remote repository on GitHub. But what if you make changes, add new files, or even delete something? Don't fret. Git makes this process efficient. You won't need to repeat all the steps. Here, let's create a new file to demonstrate. Great. Now let's write something in this file, real quick. Now that we've created a new file, let's verify the changes using Git status command. As expected, the new file shows up as untracked. This means it's not yet part of our version control. To include it and push it to the remote repository, we'll follow a simple three-step process. Step 1. Adding changes to the staging area. First, we'll use the git add command. In our case, we can use the flag to add all modified files to the staging area. This is like a temporary holding zone before we commit them permanently. Now, if we run git status again, you'll see the new file listed under changes to be committed. Step 2. Committing changes with a message. Next, we use git commit to capture these changes in a permanent snapshot. But remember, a good commit message is crucial. It explains what changes were made. A descriptive message helps you and others understand the purpose of these changes later on. You can also use git log command to see the commit history for the repository. Step 3. Pushing changes to the remote repository. Finally, to share our committed changes with the remote repository on GitHub, we use git push. This pushes our latest commit to the remote branch, keeping your local and remote repositories in sync. Let's quickly head over and see if there is any changes reflected. As you can see, it's still the same, no changes till now. Now let's push our changes. Great. Let's head over and see the new changes that we made. And congratulations, we have successfully pushed our new changes to remote. Here, as you can see, 2 commits on main branch. Great. Now your code is safely stored in your remote repository. But what if you make a mistake or need to go back to a previous version? Don't worry, Git has got you covered. Here in the coming sections, we'll explore how to use Git commands to undo changes, revert to previous versions of your code, and even restore deleted files. So let's get started quickly. Let's edit one of our file and save it. As you can see on Git status command, one file has modified. Here you can see the modification made. Either you can revert specific file or all the files by versus code extension as shown, or you can use git command as well. Bravo! We have restored our file. Now let's try to modify multiple files and restore them. As you can see, we have modified multiple files. Now let's restore them by VS Code Git extension as shown. Bravo! We have restored all of our files. Now let's try to achieve the same using git commands. For that, either you can use git restore to restore all the files, or git restore then path of the file to restore only specific file. We forgot to save the changes. Let's save it quickly and try to restore using command. Congratulations! We have restored our file. Now, let's explore another crucial aspect of Git: cloning repositories. Imagine you want to work on a project hosted on GitHub. Cloning allows you to create a complete copy of that remote repository on your local machine. Alright, let's dive into the exciting world of collaboration. Head over to the desired repository on GitHub and navigate to the Code tab. Here, you'll see options for cloning using different methods like SSH, HTTPS, and the GitHub CLI. For now, let's focus on the simplest method: HTTPS. Copy the HTTPS URL provided. We'll use this link in the git clone command to download the repository. And congratulations! Now things get interesting. Git is awesome for collaboration, but sometimes conflicts can arise. Imagine you and your coding crew are working on the same file, but you both make different edits. When you try to combine your work, Git might throw its hands up in the air, unsure of which version to keep. But fear not, future code warriors. We'll explore some advanced Git features to help us resolve these conflicts like champs. Let's try to create a conflict. Let's say one of your teammates made some changes in the same file you were working. So let's modify one of our file on remote repository. Great. Let's commit the changes, real quick. Great. Let's head over to our local project and try to modify the same file, which we just changed on remote. Perfect. Now let's try to push our changes to remote. We will see the conflict error. Remember the 3 steps to push to remote? First, git add. Second, git commit. And third, and last, git push. And as expected, we got the conflict error. But don't worry, Git got you covered. Let's fix it. We will use git fetch and git merge command to fix this conflict. So let's get started. Perfect, we have fetched the remote changes. Now use git merge to merge the specified branch into the current branch. Now that we've identified the conflicting code sections using git fetch and git merge, it's time to resolve them. VS Code provides a handy merge editor to help us through this process. Click on Resolve and Merge Editor. Here, you'll see a three-way view. Ours. This shows the changes you made locally. Theirs. This displays the changes coming from the remote repository. Merged. This is where you'll make your conflict resolution choices. Carefully review the conflicting sections. Choose the version you want to keep for each section by clicking on it in the merged view. You can also make manual edits if needed. Finally, once you're satisfied with your resolution, save the file in the merge editor. This will tell Git how you've resolved the conflicts. Congratulations! You have successfully resolved the conflicts. Now time to repeat those 3 steps to push our changes to remote. Git add, git commit, and last git push command. Great! Now let's see the commits on remote and see our changes on remote. Let's quickly reload and see the latest commit. Hold on, code development can get messy sometimes. You might be working on a cool new feature, but then a critical bug pops up. How do you tackle both without creating chaos? Show a scene of messy code. Enter the magic of Git branches. Think of them like separate highways on your code journey. You can create a new branch for each feature or bug fix, allowing you to work on them independently without affecting the main road. This keeps things organized and prevents traffic jams in your code base. As you see, currently we have only one branch, which is main. Let's see our current branch. We can check that on VS Code bottom left corner or via git command, git branch, show current. Now let's create a new branch, named as new branch. You can name it anything. For this, we will use git checkout command to create and switch to new branch. Perfect. We have created a new branch and switched to it. Time to roll up your sleeves and get coding. We're going to modify some existing files and maybe even add some cool new features to this project. And remember those golden 3 steps to push? Git add, git commit, and finally git push. But make sure while pushing the changes, change the branch name accordingly, like here we will push new branch. As you see right now, we have only one branch. Perfect. Now let's create a pull request. For those who don't know what is pull request, think of a pull request like a formal proposal. Show an animation of a pull request. You're essentially proposing your changes from your branch to be merged into the main branch of the remote repository. Click on Compare and Pull Request, as shown. Now, click on Create Pull Request. Here you can compare the file's changes, commits. Once done, click on Merge Request. And congratulations, you have successfully merged your changes to main branch. You can now delete the new branch if wanted. Here, as you see, there are 2 branches now, main and new branch. Now that you've explored modifying files and creating a pull request, let's talk about staying in sync with your team's work. The git pull command is a powerful tool that helps you fetch the latest changes from the remote repository and merge them into your local branch. Let's see it in action. Let's switch branch to main from new branch. Use git checkout command to do that, as shown. Perfect. We are now on main branch, but seem like it's not the latest data from remote. Let's check the remote. Did you see that? We have to fetch the latest data from remote. Here's git pull command. Let's fetch the data quickly. Congratulations! You've officially conquered the basics of Git and GitHub. You're now a Git master in the making. But remember, the Git journey never truly ends. There's always more to learn, like advanced branching techniques and those tricky merge conflicts. But hey, that's what makes coding exciting. A huge shout out to our amazing community for reaching 100 subscribers. We couldn't have done it without you. As we keep growing, let's set our sights on 500 subscribers. To celebrate reaching 100 incredible subscribers, we've stashed some awesome Git resources in the video description below. There's a handy cheat sheet and a cool flow diagram to help you navigate the world of Git like a pro. Keep coding, keep learning, and keep rocking.